Okay, now we go to 11.2, the binomial theorem. So for 11.1, we are using Pascal triangle to expand a plus b power m for any positive integer n. But if n is large, it can take a long time. Okay, combination can be used to help expand binomial expression more quickly. Okay, so use the combination will be more quickly. But for me, this one is the n equal to 5. I can do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. I think this is still easier compared to using the binomial lah. Okay. In case if we have value larger than very large, like 10, 11, 20, something like that. So we will use this. This 5C0 is 1, 5C1 is 5. So C is combination. You can see that I have the 5C1, I have 5. And the 5C0 is 1. And 5C2 is 10. And 5C3 is 10 as well. And 5C4 is 5. And 5C5 is 1. You can see that the NCR here is symmetric. 10, 10, 5, 5, 1, 1. Symmetric. It is symmetric. Okay. So the expansion for a plus b power 5, it will become 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, a power 5, a power 4, a power 3, a power 2, a power 1, and then no a, b power 5, b power 4, b power 3, b power 2, b power 1, no b. Okay, in general, the a plus b power n will be nc0 a power n plus nc1 a power n minus 1 b power 1 c power nc power 2 nc2 a to the power n minus 2 b power 2. You can add up these two power, it will become n. Okay, minus 2 plus 2 don't have, minus 3 plus 3 will remain m, something like this. Okay, so but nc0 is 1, this is 1, ncn also 1. Okay, any number we have the, let's say I have 8c8, it will become 1, and I have the 8c0 is also 1. Why it is 1, I will explain later. So we can simplify as a power n, this is b power n, and then nc1 a power n minus 1 b power 1, nc power 2 a power n minus 2 b power 2, and so on. So the nc1, okay, we have the ncr here. The ncr here is also, we can write as nr here. So the nc1 n1, nc2 n2, nc3 n3, ncr nr is something like this. Okay. So the, even I can write more general, it is sum of ncr a power n minus r and b power r, like this. And the r is from 0 until n. Okay, this is not covered yet also. This symbol stands for summation of sum from. Okay, so the formula here are known as the binomial theorem. So for this case, the work example number 3, they want us to use the binomial theorem to expand this one. Okay, so we have the 3 plus 4x to the power of 5. Okay, if I use Pascal triangle, I'm using Pascal. If I'm using Pascal, it will be 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 6 1. So okay, 5 1 5 no 1 5 10 10 5 1. Okay, so this one will be 1 5 10 10 5 1 3 power 5 3 power 4 and then 3 power 3 and 3 power 2 3 power 1 and this will be 4x power 5 4x power oh so this will be 4 so, okay, so we have 4x power 4 and 4x power 3 4x power 2 and 4x here. Okay, so this will be the answer. 3 to the power of 5 is 243 plus this one 5 times 3 power 4 times 4 is 1620x plus this one 10 times 3 power 3 and then multiply with 4 square. It will become 4320 x squared and this 10 times 3 square times 4 to the power of 3 it will 5760 x power 3 5 times 3 times 4 power 4 it is 3840 x power 4 and we have 1024 x power 5. Okay, 4 power 5 is 1024. Okay, so this will be the answer. What I'm doing here in the exam is not acceptable. Okay, why it is not acceptable? Because I'm not using binomial theorem. So if we want to use the binomial, so what we need to do here, it will become 3 plus 4x power 5 is the 3 power 5 plus this one is 5c1, 5c2, 5c3, 5c4, 5c5 no need to write. And then 3 power 4, 3 power 3, 3 power 2, 3 power 1. Okay, then we have the 4x power 5, 4x power 4, 4x power 3, 4x power 2, 4x power 1. Okay, so you can see that this 3 power 5 will be the same. And the 5c1 multiplied with 3 times 4 multiply 3 power 4 times 4 same. Okay, and then I have the 5c2 3 power 3 and then 4 square it will be 4320 and the 5c3 3 power 4 and 4 power uh this will be no this is not 4 this will be 2 and then this is the no this is 3 5c3 5c 5c3 or 3 power 2 okay 3 power 2 4 power 3 then 5760 and we have the 5c4 3 power 1 and 4 power 4 okay 3840 and this one the last one actually is 5c5 5c1 no need to write and 3 power 0 also no need to write and this is 4 power 5 okay just 4 power 5 is enough lah. Okay, so this one is exactly same with this one. Okay, same, the whole thing. Okay, just the step that you need to write is different for the binomial distribution compared binomial theorem compared to the Pascal triangle. My own opinion, okay, if the power is less than 10, I'm still using Pascal triangle will be easier. So if the question didn't ask us specify that ask us to use binomial theorem, then we can use Pascal. So what is the benefit of using Pascal? Is it is good for you to do the programming. Okay, so actually we can do something like this in the calculator. We have the 5cx multiply with 3 to the power of 5 minus x, then multiply with the 4 to the power of x, and I calculate, press the CLC, I put 0, then it will return 245, 243. And I press CLC again, I put in 1, then after we substitute 1 here, it will become 1620. And I substitute again with 2, it will return 4320. And CLC, I substitute with 3, 5760. And I substitute with 4, it will become 3840. And I substitute with 5, okay, just now I calculate 5, then it will have 1024. So even I can do something like this, it is more powerful. So this one, the first, just now when I'm doing this, I'm doing manually. And now I'm setting a formula in the calculator and I substitute the value inside. Okay, so for those who calculator have table, it can be more. You have something more advanced that you can do is you call for table. Number 9, table. Then this will be 5cx multiplied with 3 to the power of 5 minus x and multiply with 4 to the power of x. And then I press equal. The calculator will ask for gx and I press equal again. Ignore the gx. I start from 0. N and 1. Step size is 1, that means it will be 0, 1, 2, 3, 4, 5. If step size is 0.5, then it will become 0, 0.5, 1, 1.5, 2, 2.5. The gap between the number is 0.5. So the gap between the number is 1. Then I press 1, the calculator will return this one, this table. Okay, so you can see that the value 243 162043205760 and so on. Okay, so you do it manually, you have found that it is difficult, but actually if you know programming, you do it programming, you ask your calculator or you ask your computer to do this, then when you set in, this one will come out. So this is very powerful when you are doing programming using binomial. Using 570 ms, so you don't have table there. What you can do is you do the 5 shift C, divide the NCR here, C, and alpha x multiply with 3 power 5 minus alpha x, and you close the bracket, multiply with 4 to the power of alpha x, and you close the bracket again. After that, you press CALC. They will ask what is the value of x, you substitute 0, and then you press equal and equal again. Then it will return 243. Okay. So it will return 243. Mm. And then you press the CALC again. You press 1 and then press equal, then equal, and it will return 1620. And you press the calculate again and press 2 and equal, then this is 4320. And you press the CLC and you substitute 3, then it is 5760. And you press the CLC again, you key 4, it will become 3840. And you do the CLC, press 5, then it will return 1024. So binomial distribution is friendly to calculator and to programming in the computer. Okay, but if you need to do the calculation by yourself, it's a little bit difficult compared to the Pascal triangle. This is what I will say. Okay, for work example number 4, they want to find the coefficient of x power 20 in the expansion of 2 minus x to the power of 25. Well, this will be very difficult. We know that it is 25. Okay, we have this one, we have the 25 r, and then 2 to the power of 25 minus r, and negative x to the power of r. So we can see that this is 20. So the r is actually 20. So we have the 25, 20, or 25C20, and 2 to the power of 25 minus 20, negative to the power of 20. Okay, so negative 1 to the power of 20 is 1. Okay, so we have the negative 1 to the power of 20, it will become 1. So the negative sign here we can ignore. So we have the 25C20 multiplied with 2 to the power of 5. 25 minus 20 is 5. Then this will be the answer. Okay, so it is 1700160. Okay, 1700160. Yes, 1,700,000 and 160. Using this same example, in case if this one they want x power 20, in case is the question one x power 10 only, then what will be the answer? So for this one, it will be 25C10 and 2 to the power of 25 minus 10, negative x to the power of 10. So it will be something interesting. 25C10, 2 to the power of 15. Okay, then this is the value. It's something, a very large value. Okay, try one more. If we have the x to the power of 4, x to the power of 5 here, then it will be, no, I don't want 5. Yeah, I can have 5 here. So we have the 25C5, 2 to the power of 25 minus 5, negative x to the power of 5. It will be a very large value also, 25 C5 2 to the power of 20. So it will become negative x power 10. This is x power 5. Why it is negative? Because negative 5, negative 1 to the power of 5. So negative 1 to the power of 5 is negative. Negative 1 to the power of 10 is positive. Okay, if we want to have the x to the power of something like 23 lah. So we have 25 C 23 2 to the power of 25 minus 23 negative x to the power of 23. So we have this one 25 power 23 and then this one is 25 minus 20 25 minus 23 is 2. Okay, so this is 1200. But because this negative 1 to the power negative the power 23 is negative, so it will become negative 1200 x to the power of 23. Okay, so this is x power 20. So the coefficient, okay, so the coefficient x power 20, okay, is 1700160. Okay. Observe that this one is negative 1 to the power of 20. Power even number, it will become positive. Negative 1 to the power of 10, then it will become positive. Negative 1 to the power of 5, odd number, then it will become negative. Negative 1 to the power of 23, then it will become a odd number as well. So calculator, if I use table here, okay, if I want to have the negative 1 to the power of x, I start from, let's say, 1 to 5 lah. So you can see power 1 negative, power 2 positive, power 1 negative, power 2 positive, power 1 negative, power 2 negative. It will be alternate. Positive, negative, positive, negative, positive, negative. Okay, like what we see on the previous 5.1 part. If it is power, it is negative here, then the final result we have alternate sign, positive, negative, positive, negative, positive, negative. If positive, all positive. But if negative, it will the first one positive, second one negative, and then so on, positive, negative, positive, and then negative. It is alternate. Okay, we look at this. If we are using binomial theorem, 1 plus x to the power of 7, it will become 1 power 7. And then 1 power 6, 1 power 5, 1 power 4, 1 power 3, 7c1, 7c2, 7c3, 7c4. And then x power 1, x power 2, x power 3, x power 4, and so on. And what we have is 7c1, 7c2, 7c3, 7c4. So 7c1 will become 7 factorial over 1 factorial 6 factorial. Okay, this one because we have the NCR. Okay, so the definition for NCR, if you no idea about this one, I will introduce to you here. It will be n factorial over n minus r factorial and r factorial. Okay, so we have the 7c1, it will become 7 factorial, 7 minus 1 factorial, and 1 factorial. It will become 7 factorial over 1 factorial, 6 factorial. Okay, we know that 7 factorial is actually 7 times 6 times 5 times 4 times 3 times 2 times 1 and so on. Okay, this is the definition of factorial. So we have the n factorial is actually n times n minus 1 multiply until 3, 2, 1 and so on. And this one, I know 6 times 5, 4, 3, 2, 1 and so on is actually 6 factorial. So this one and 1 factorial is actually 1. So this will become 7 times 6 factorial over 1 times 6 factorial. And the 6 factorial and 6 factorial we can cancel. Then what will you remain is 7 over here. Okay. So this is NCR lah. We should never learn this before. It is something new and the factorial also new. So on, we have the 7C2. It will become 7 factorial because n factorial, 7 factorial, n factorial, 7 factorial. And then we have the 7 minus 2 is 5 factorial and 2 factorial, 2 factorial, 5 factorial. And this 7 factorial, it will become 7 times 6 times 5 factorial. And the 5 factorial and 5 factorial here cancel. Then it will become 7 times 6 over 2 factorial. Okay. So for the next one, we have the 7C3. So for 7C3, it is 7 factorial, 7 minus 3 factorial, and 3 factorial. So this is 7 times, this is 4 factorial already. So this is 7 times 6 times 5 times 4 factorial over 4 factorial times 3 factorial. So this one we cancel. It will become 7 times 6 times 5 over 3 factorial. 7 times 6 times 5 over 3 factorial. And we have the 7C4 here. It will become 7 factorial, 7 minus 4 factorial, and 4 factorial. So this one is 7 times 6 times 5 times 4 times 3 factorial over 3 factorial, 4 factorial. So this one we cancel. So what will remain is 7 times 6 times 4 times 5 times 4 over 4 factorial is this one. Okay. So you can see 7 times 6, 7 times 6 times 5, 7 times 6 times 5 times 4. And then they divide by, actually this one is divided by 1 factorial, 2 factorial, 3 factorial, 4 factorial, something like this. Okay. So, and then x power 1, x power 2, x power 3, x power 4. So, in general, the binomial expansion will be 1 plus n times x n minus 1 over 2 factorial x squared, n minus 1, n minus 2, 3 factorial over 3 factorial x power 3, n minus 3, n minus 1, n minus 2, n minus 3 over 4 factorial x power 4. So you see, if we have the 7, 7, 7 minus 1, 6, 7 minus 2, 5, 7 minus 3, 3, 4, and then over 4 factorial times x power 4. So this is binomial expansion. So actually we are solving the same question, just using different method lah. So this is the third method. So the first method we are using Pascal triangle, second is binomial theorem, and now we are using binomial expansion. Okay. Look at the work example number 5. I have the 1 plus 3y to the power of 7. They want you to write the first 4 terms of the binomial expansion. So for this one, if I don't want to use the binomial expansion, I'm using the Pascal. Using the Pascal, it will be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, and 1, 7, 21, 35, 35, 21, 7, and 1. So this one, power 7, it will be 1, 7, 21, 35. And we have the 1 to the power of 7, 1 to the power of 6, 1 to the power of 5, and 1 to the power of 4. And we have the 3y to the power of 0, so we don't write it here. 3y to the power of 1, 3y to the power of 2, and 3y to the power of 3. So what we have will be 1 plus 21y plus, this is 21 times 3 square. Okay, mod 1, 21 times 3 square is 189y square plus, this is 35 times 3 to the power of 3. It was 945y to the power of 3. Okay, so if we are using the binomial expansion, just now this one is the binomial expansion. So 1 and then n minus 1 over 2 factorial x squared, n minus 1 n minus 2 over 3 factorial x cubed. So this one, we have the 1 plus 3y power 7. Binomial expansion, the first term here, this one must be 1. Okay, must be 1. If it is not 1, you cannot use this method. Okay, so for this one, it will become 1 plus 7 times 3y plus 7 times 6 over 2 factorial 3y square plus 7 times 6 times 5 over 3 factorial 3y power 3. So it will become 1 plus 21y plus 21, this one will be 7 times 6 divided by 2 factorial and then multiply with 3 square, 189. 189y square. This will be 6 times 6 times 7 times 6 times 5 divided by 3 factorial multiply with 3 power 3, 945. This is 945y power 3. Yes, if we are using binomial expansion, it will be easier. Okay, so for part B here, I'm using the Pascal triangle again. So this one, if I'm using the Pascal, then it's 1, 6, 15, 20. 1, 6, 15, and 20. So we have the 2 power 6, 2 power 5, 2 power 4, 2 power 3, and then we have the negative y power 1, negative y power 2, and negative y power 3. Okay, so 28、16、32、64、64 times plus, this will be minus already. 6 times 2 power 5, 192, 192y. Plus, this one is 15 times 2 power 4, 240 y squared. And minus 20 times 2 power 3 is 160 y power 3. It will become plus minus plus minus, and then we so on, plus dot 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 and plus dot dot dot. That means we still have something behind. Okay, so this is Pascal. Question: if you want to use binomial expansion, it will be very difficult. Little bit difficult. Why it is difficult? Because you have to do some adjustment. Okay, because like what I said just now, for binomial expansion, it must be 1 in front. It is not 1, then you have to change it to become 1. How to change to become 1? Then what I have is I do the factorization. So if I have the 2 minus y, I factorize 2. Then it will become, okay, I want to factorize 2. then it will become 2, 1 minus y over 2. Then some student will ask, teacher, why you factorize 2, it will become something like this. It is because when you factorize 2, then that means you divide 2 here and divide 2 here. Divide everything with 2 inside. So this one will become 1 minus y over 2. So this will become 2, 1 minus y over 2, then the whole thing power 6. So this will become 2 power 6, 1 minus y over 2 power 6. We can compare this one, 1 plus x to the power n, with this one that we have find here. So you can see that 1, 1 are the same. Then the n here is 6. And the x here is negative y over 2. So, okay, so we have 2 power 6. 2 power 6 is actually 64. 28, 16, 32, 34. 64. 1 plus, you can see this is 1 plus nx. So we have the nx is 6 negative y over 2 plus 6 times 5 over 2 factorial negative y over 2 square plus 6 times 5 times 4 over 3 factorial negative y over 2 power 3. Okay, so this will become, okay, 64. 1 minus 3y. 6 divided by 2 is 3. And then we have the 6 times 5 divided by 2 factorial. 2 factorial is actually 2 lah. And then divide by 2 square. Then it will 15 over 4 plus 15 over 4 y squared. And then we have the 6 times 5 times 4 divided by 3 factorial divided by 2 power 3. This one 6 times 5 times 4 over 3 factorial. This is 2 power 3 divided by 2 power 3. 5 over 2. So it will minus 5 over 2. Negative 1 to the power 3 is negative y power 3. And so on. So I multiply the 64 inside, then will be 64 minus 64 times 3, 192. And then we have the 64 times 15 over 4, then 240, minus 64 times the 5 over 2. Okay, then it will become 160. So you can see that this one, 64, negative 192, 240, and negative 160 are the same. But this one, we are using the binomial expansion. So for the same question, we can solve using different method. Okay,